Okay, in this video I'm just going to be doing a little recap of probability work you've done before. Might go a little bit further, but this is just to get your brains into probability mode for what comes next. Okay, so as with many things in year 8, it's stuff you've done before, but taking it a little bit further. So probability is your heading. And we'll start with the two sort of basic rules here. Probability can be measured using fractions, decimals, or percentages. And I know that lots of you don't like working with fractions, but a lot of the time it really is the easiest way of doing probability. Okay, and probability is always measured out of 1. So if it was a fraction, 1 would mean like 8 out of 8, or 6 out of 6, or 10 out of 10. That would mean 1. If you're working in decimals, then it just goes from 0 to 1 anyway. And if you're working in percentages, 1 is the same as 100%. Okay, so what we have is probability scales or probability lines, and you've seen this one before. So this is what you would have done in year 6 of primary and again in year 7, where we describe probability in words. So down this end is 0 chance of something happening, impossible. At this end is a 100% or a 1 chance of happening, which is certain. In the middle was even chance. And you would have said as well that down this end is unlikely, and at this end is likely. Okay, but that doesn't really help us, because if I've got an event there and an event there, they've got different probabilities, but they would both be unlikely. So we need to measure probability more accurately than just words, because even though even chance is specifically in the middle, impossible is specifically there and certain there, everything else in the middle is a bit wishy-washy if you're just going to use phrases like likely and unlikely. So that's why we measure it in a number form, so a fraction, a decimal, or a percentage. So if you draw a new number line, so this will be our fraction line. So it still goes from 0 to 1. Even chance would be a half, okay? Or fractions that are equivalent to a half. So it could be 4 out of 8, that's still a half. It could be 6 out of 12, that's still a half, okay? And we could even add on a quarter chance there, if you split 0.5 in half. And if you split that halfway, that would be 3/4. And all sort of normal fractions, obviously you can't go top heavy because that's bigger than 1, so all normal fractions where the numerator is smaller than the denominator are on that line somewhere. So for instance, 1/5 would be roughly there, 7/8 would be there, and you can go anywhere on that line if you get the right fraction. And fractions are really good when you've got like a strange number of objects. If you've got 10 objects in a bag, then that's easy to do as a percentage, it's easy to do as a decimal. But if you've got 7 objects, then it becomes really hard to work in decimals, because 7 is not a very nice number for converting into decimals and percentages. So that's a fraction probability line. Then we've got a decimal probability line. So if I've got 0 for impossible and 1 for certain, the decimal in the middle would be 0.5. And you can put any decimals on here. So a quarter would be equivalent to 0.25. So that can line up with a quarter there. 3/4, hopefully you know, is 0.75. And you can put any decimal you like on there. So really small could be 0.05. Okay, or quite big might be 0.9. So that's another way of measuring probability. And if we keep going down, the last number line you'll need to draw, we don't use percentages very often, but you can use percentages. So halfway would be 50%, quarter would be 25%, 3/4 would be 75%, and you can put anything you like in the middle. So I could put 60% would be roughly there, wouldn't it? Okay, 45% there. But we tend to, in maths, use fractions if we can, and decimals sometimes, but very rarely percentages. So it's working with fractions and decimals mostly in this topic. Now, when you're working in fraction form, you have to follow this little formula, which looks worse in words than what it actually is when you look at an example. So the probability of something happening is equal to the number of successful outcomes divided by the total number of outcomes. And outcomes are just things that might happen. So if I've got a coin, there are two outcomes. There's heads or tails. There's only two things that can happen. If I roll a die or a dice, there are 6 outcomes because you can get 1, 2, 3, 4, 5 or 6. So outcomes is just all of the different things that could happen. And then successful outcomes is, well, what do you want? So if you're playing a game and you need to roll a 6, then there's only one successful outcome on a dice because only one of the sides has got 6 dots on it. So you'd have a 1 out of 6 chance. If you're flipping a coin and you need heads to win, well, there's only one side which is heads, and there's 2 sides altogether, so 1 out of 2 are half. If we have a look at an example here, now if you've got colours, it would be nice for you to do this exactly like I've got it with reds and greens, so maybe pause the video and go and find some colours. The first thing you're going to need to do here is count up all of the shapes, because that's going to be our denominator. The total number of outcomes is the total number of shapes. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So whatever I'm counting now, the probability will be out of 9. And what I'm going to do, I'm going to use the sort of the short way of writing this. So capital P stands for probability. If I said the probability of picking a circle, all right, so rather than writing the word probability, just capital P and then in brackets means probability of picking a circle. So all you do is count the circles, the ones that you want. So 1, 2, 3, 4. So 4 is the number of successful outcomes. There's 4 circles. And 9 is the total number of outcomes, the total number of shapes. And it's really that easy to make a fraction in probability. If I said the probability of picking a red triangle, okay, the probability of picking a red triangle, there's only 2 of them, so that would be 2 out of 9. The 9 doesn't change because there's still 9 shapes. If I say the probability of getting a green shape, and this time I don't care what shape it is, as long as it's green, there's 5 green shapes out of 9. 9 is not a number that converts to decimals and percentages very easily, so it is definitely better to leave them as fractions out of 9. I've got another example here with a spinner. Okay, so you know, you can either put a pencil through it and spin it around on a table, or you might have like an arrow like in Twister where you spin the arrow around and see what it lands on. So on this spinner there are 1, 2, 3, 4, 5, 6, 7 outcomes, because there's 7 areas, there's 7 numbers on the spinner. So all of my probabilities this time are going to be out of 7. So if I said what's the probability of landing on 6, so you would count the number of 6s on the spinner, and there's only 1, so it would be 1 out of 7. You've got a 1 out of 7 chance. If I said the probability of landing on 3, that's a bit different because there's 2 3s. Look, there's 1 there and there's 1 there. So that would be a probability of 2 out of 7. You're twice as likely to land on it. If I want to make things a little bit more complicated, I could say, what's the probability of picking a multiple of 3? Now, a multiple of 3 is the posh way of saying anything in the 3 times table. So that would include 3s, both of them, and 6, and 9. So my probability would be 4 out of 7. Okay. The probability of me not getting a multiple of 3 would be 3 out of 7. The chance of me landing on something that's not in the 3 times table, okay, would be 3 out of 7. And of course, between them they make 7 out of 7, which is 1. Okay. If you're working with decimals, the biggest thing to remember is that the decimals must add up to 1. Okay, they can't go more than 1, they can't be less than 1. So if you have sentences like this, the probability of winning a game of tennis is 0.7, and tennis is a game where you can't draw, you either win or you lose. If you watch a tennis match, they sometimes go on for a long time trying to decide who wins, but there's always a winner, there's always a loser, you can't draw. So I can work out the probability of losing in tennis because I kind of just say, well, if I've got a 0.7 chance of winning and it's got to make 1 altogether, what do you add to 0.7 to make 1? Or what is 1 take away 0.7? And that would be 0.3. 0.3 and 0.7 make 1. Okay, so it can't be any other number. It couldn't be 0.2 because that doesn't add up to enough. It couldn't be 0.4 because that adds up to too much. They've got to make 1. You know, and it's easy in this one because there's only 2 outcomes. You either win or you lose. If I had a sport like football, I'd have to know winning and drawing to work out losing. Okay. If it says the probability of it raining tonight is 0.2, which is not likely because as I'm making this video it's absolutely hammering down outside. So the probability of it not raining tonight is the missing decimal to make it add up to 1. So what do you put with 0.2 to make it add up to 1? It would be 0.8. And then I've got one more of these, and then you'll be okay to do a little probability sheet for me. If the probability of picking a red ball is 0.35, then the probability of not picking a red ball, because I don't know how many other colours there are, so I can't say like blue, green, yellow, because I don't know what they are, but I can say that not picking a red ball, so whatever else is in there. So a little bit trickier this time. So 1 take away 0.35, you can think of it like money, couldn't you? So if you've got £1 and you spend 35 pence, what's left would be 0.65. Be careful, it's not 0.75, it's 0.65. So that must be the chance of not getting a red ball. So I don't know if it's green, yellow, blue, purple. I don't know that, but I do know that if the probability of getting a red ball is 0.35, then the opposite, not getting a red ball, is 0.65. And that's all you need to know for probability for now. And then we'll take it a little bit further next time.